So we're going to continue along today with solving systems, and we're still going to kind of be looking at solving systems by graphing, except we're going to look at a very specific piece of systems where we are going to be looking at solving systems of inequalities, okay? So these are going to be systems of inequalities, which means exact same rules that we had yesterday, but instead of an equation, it's going to be an inequality, which means we need to remember our rules for graphing inequalities. Okay, so before we do anything with graphing a system or anything of that nature, let's just talk about graphing a system to start with. So let's say we want to graph y is greater than 2/3 x minus 7. Okay, remember, we graph these just like we do slope-intercept form, which means they always have to be solved for y. Okay, if it's not solved for y, our rules of shading above and below aren't correct. So make sure we're solved for y. Okay, and then we're going to solve just like we do in slope-intercept form. So my m is 2/3, my b is -7. So I'm going to start at -7. Okay, and I'm going to do a slope of up 2 over 3. Up 2 over 3. Now, today our lines don't have to be quite as perfect. So getting as many points isn't quite as necessary, but we do want to make sure that we're getting lines that we can definitely tell sort of where they overlap. So not too crazy or too crooked. So once we make those points, remember, then we're going to look over here at this inequality sign, and we have to make some decisions. Does this inequality symbol tell us that we want to use a dashed line or a solid line? We should have picked a dashed line. So remember, the rule says if we have anything that is greater than or less than, it is going to be dashed. If it is greater than or equal to or less than or equal to, it is going to be solid. Okay, again, looking at that inequality sign, does that tell us for this particular problem we want to shade above or do we want to shade below? We should have said above, right? Greater than or equal to tells us to shade above. Less than or equal to tells us to shade below. Okay, so if I'm going to be shading above, I'm going to shade all of this area above. And remember, we talked about the idea that we might want to make it so that we're right up against the line and all the way across. So that's exactly what we want to be doing here. We want to get all the way across the line and all the way down. This is where it's going to be important so that we can make sure we're really seeing where they overlap as we move forward. Okay, so we're then going to transition to what does this mean for a system of inequalities. Okay, so I'm not going to rewrite down all of these rules because we should already have them in our notes and we just reviewed them. Okay, so unless you feel like you need to rewrite, you can rewind and look back at that last problem and it will have all those rules. Just like yesterday, we are going to have two equations, well, two inequalities, and we're going to have two variables. And when we have two different lines happening on the same coordinate plane, three things can happen. Those lines can intersect. Those lines can be parallel. Or those lines can be the same. Okay, that's exactly what we looked at before, but now we're opening the door for a whole lot more info. So when we're looking at this, right, we are now not talking about a single answer. Just like when we said x equals 2 was one answer. X being greater than 2 was an infinite number of answers. So that's the exact same sort of issue we're going to run in today. So when we have intersecting lines, we're not going to have one solution. We are going to have one area. Okay, when we have parallel lines, we're now going to get some options. Okay, parallel lines could still be a no solution, but parallel lines can also be one area. If that wasn't complicated enough, when we get to the same line, okay, it can just be the line It could be a no solution, or it could be one area. So we definitely have a lot to think about as we're doing these problems. So it might be helpful if you have two colors to write with, like two different colored pens, two colored pencils, a pen and a pencil, something of that nature. We're going to take the same approach that we took yesterday. So we have a system sitting over here. Y is less than 4x plus 2, and y is less than or equal to 1/2 x. And we are going to think about these one at a time. So I'm going to start by just looking at my first one. Y is less than 4x plus 2. Okay, that tells me that my slope is 4. My intercept is 2. Okay, this particular inequality tells me it's going to be a dashed line and that I'm going to shade below. Okay, so I want to start at 2, and then I'm going to do a slope of up 4 over 1. Up 4 over 1, right? This is a dashed line. So I've got a dashed line going down. And I want to shade below. Again, following that rules, make sure we're getting all that shading. Otherwise, we won't see our answer for the system. Okay, so let's look at our second one. Y is less than or equal to 1/2 x. What does m equal? We should have picked 1/2. What does b equal? We should have picked 0. Is this inequality going to have a solid line or a dashed line? We should have picked solid. And are we going to shade above or are we going to shade below? We are going to shade below. So we are going to go over to the same coordinate plane, and it's going to start to get kind of messy kind of fast. So we're starting at 0, and I want to go up 1 over 2. And this is where that second color is really helpful. Okay, I'm just going to make enough points here so I can sort of make sure my line is decently straight. This one is a solid line, and I am going to shade below. Now, yesterday, we were looking for where the two lines would intersect. Well, we're doing that same thing today, except now we're looking where the two areas intersect. Or where do we see red and blue happening at the exact same time? Right? So if we remember correctly, when we were talking about graphing inequalities, we would say that this point over here is not an answer, but this point over here, because it's in the shaded region, is an answer. Right? And this point right here that's on the line is not an answer because that line is dashed. Right? And dashed lines just tell us how close we can get. We can't actually stand on them. So that's the same approach we're looking for over here, except now we're doing it with two different areas. So we want to know where we see red and blue at the exact same time. And that red and blue is happening in this area over here. Okay, so if you're doing this by hand, you're going to actually have to shade in darker, which is why we didn't want to shade too dark to start with, or we wouldn't be able to tell. Okay, so now I want you to make some decisions here, and this is where we have to really use our brains. Okay, I'm going to make some different points. Just put one over here, and we're going to decide which of these are answers and which are not. Okay, so if we are looking at this and this is point A, is A a solution? We definitely should say no because it's not anywhere in a shaded region. Is point B a solution? B is not a solution because it is only where the red exists. Is point C a solution? C is not a solution because it is only where the blue is. Is D a solution? Yes, D is a solution because it is where they both overlap. How about point E? Point E is a solution because it is on a solid line and the red is happening underneath it. So then what if we talk about a point over here on this line? Yep, this point F is not a solution because it is not on a solid line. Okay, so if we understand all those concepts, this should start to go a little bit quicker now as we're looking at solving and graphing these. So example 2, 2y is less than or equal to 6x minus 8. So we're going to need to solve this by dividing by 2. Oops, let me get my pen. So when we solve this, we get y is less than or equal to 3x minus 4. Now, I just wrote this stuff down so you would remember to think about it. You won't actually be given that. So if we want to graph this, we're going to start at negative 4. We're going to go up 3 over 1. Okay, is this going to be a solid or dashed line? We should be making that's a terrible line. We should be making a solid line here, and we should be shading below. Then we are going to look at our second equation, inequality, I should say. Our second inequality also has to be solved for y. So our solving for y skills, again, we're still using them. Subtract that 9x from each side. Okay, so now we're going to divide by negative 3. When we divide by negative 3, what do we need to do? We need to flip the inequality sign here. So this really becomes y is greater than 3x minus 4. Okay, so when I graph this, I'm going to start at negative 4, and I'm going to go up 3 over 1, up 3 over 1. Okay, this one is a dashed line. And this one we are going to shade above. What do you think the solution is to this one? We should have picked no solution. So it's kind of difficult to think about because those two lines fall right on each other, right? And if they're the same line, don't they overlap? Well, they don't actually overlap, right? That dashed line says we can be as close to that line as we want to be, but it is not actually there. So to get an answer that's just the line, all that would need to happen is that if we have this or equal to right here, then our final answer would be the actual line. Oh, that's terrible, but you get the idea, right? This part right here would be our final answer. Okay, but because we don't have that, we actually don't have anything that overlaps, and this ends up being a no solution. Okay, we should also make sure that we are still okay with our vertical and our horizontal lines. So if we have x is less than 5, I know I keep repeating this and making sure we're okay with this. X equals 5 is a vertical line. So this is a vertical line at x is 5. Okay, it's just less than, so that means a dashed line. Now we've talked about this before, but for a less than sign on this one, are we going to shade to the right or to the left? We should have picked the left, right? Less than is lower. Numbers that are less than 5 are 4, 2, negative 2, right? These numbers over here. So we want to shade all of this area. Okay, then we have x is greater than 2. So if we want to do x is greater than 2, what type of line is this? This is a horizontal line. So at 2, I want to make a dashed horizontal line. And this one is telling me to shade above. So my final answer is going to be all of the points that exist in this area up here. So if I said, okay, pick a possible solution, okay, we should understand that this is an infinite amount of points, right? I could start listing just point, right? There's all these points. But if I say just pick one, all you would have to do is name any point that exists inside this orange area. So maybe you pick the point 0, 4. Maybe you pick the point 1, 8, 2, 10, Negative 2 comma 1, that's not a solution because we're not up in the orange area. Okay, negative 2 comma 2 is not a solution because that's on a dashed line. Okay, but if I get all the way up here to negative 2 comma 3, now I'm at a potential solution. So I want to show you how this is going to work in Delta Math. Hopefully it didn't time me. Oh, it did. Okay, so in Delta Math, if you are doing this, I'm just going to open this up again really quickly. You're going to log in. Okay, you are going to see an assignment today for inequalities. Just like when we've done graphing before, it's really nice because it takes care of all of the graphing portion for you. That's not actually what I want to do. Pull up a sample this way. Okay, so here's what this is going to look like. Okay, and it's going to ask you to graph them both. So as you start to graph a line, the second line is just going to show up for you. So if we start with this first one, right, this says to start at negative 2 and then a slope of down 1, right 1. Okay, so now once you have this line, now it's going to allow you to do whether you want it dashed or solid and whether you want it to shade above or shade below. Okay, so this one I want solid and above. Then you're still going to be able to make points for your second line. So now I'm going to start at positive 7. Up 1, right 2, and now my second one appears. Right, this one I want to be dashed, and this one I want to shade above. Okay, so now I can see my overlapping area is up here. And what you are then going to have to do is pick a possible point that's a solution. So any point that exists over here is a possible answer. Okay, so I'm going to pick the point negative 4, positive 9. So I'm going to type in negative 4, positive 9, submit that, and I'm good to go. Okay, so you're going to go through and finish this as your assignment. If you have any questions, feel free to email me and let me know. Otherwise, good luck.